Yeah, guys, I'm solving short of arrays of 0, 1s and 2s. So we are giving array of arrays containing array sizes and is containing numbers 0, 1s and 2. So if it is only containing 0, 1 and 2, we have to sort the array in ascending order. So all the zeros comes in the left part of the array, then 1s, then all the 2s come to the right part of the array. So yeah, so we have to solve this question. So first thing I am using solving this using sort. I am sorting the array is sorted, and here is the answer. Yes. So the time complexity of this sort is big of n log n. Now method 2 using so in this method what I'm saying is I am counting how much zeros in the array, how much twos in the array, how much ones in the array, and then rearranging all the elements like this. Yes. Now I am now iterating through the array and put how much zeros in the end. Now I'm putting back these zeros in the array. So I'm just changing the array now. So I'm first run this. There is some error. So what the error says, count of 0 is correct, count of 1 is correct, count of 2 is not correct. Okay, so what's wrong is count 2, count 0, count 1. This is starting from count 0 and running till count 0 plus count 1. It's okay. And then j is increment and j is 1. And now the third loop is running from k is nothing but count 0 plus count 1, where this loop terminates. Let's mention count 0 is 2, then 0 1, then it's 3, then 2, 5, 4, 5 till you can say same thing. The problem is not there. Problem is there. There is some problem. There is some issue. That's why to-dos are printing. Okay, let's see what's the issue. I don't think so. There is some error. Why this code is not running perfectly? The problem is there now. Are the values of initialized zeros? Now this will run perfectly. Yeah. So now submit this. Now I am third algorithm. So low is nothing but 0, mid is nothing but 0, and high is nothing but. So low and mid start from beginning of the array and high is the end of the array. Now where it will be root, where mid is the end, where mid is the last of the element. So I'm saying if ARR of mid, ARR array, so A of mid is nothing but 0, then what we have to do? If it's 0, then we have to put in the fair zeros end. And according to algorithm, zeros are till start to low minus 1. So we have to put it. So we have where we have to put it? ARR mid, ARR low. So ARR low, we have to swap ARR of mid. And we can say this thing are correct. One at its position, because according to this algorithm, all ones are the mid of the array. Mid. We have to move mid, then we have to move low. You can say we have say if it's 1, then what we have to do? This is the correct position. We have to do nothing. Else if it's 2, then what we have to do? We have to swap, where we can say 2's are at high plus 1 till and minus 1. Put it very high plus 1. It's high. So swap ARR high and ARR mid. Now we say high plus 1 till and minus 1 are in the sorted order. Now high moves now high till and minus 1 is sorted order, then high moves down. So high minus minus and mid plus plus. No, you don't have to do, because if there is 0, then you have missed it in the mid. If it's 1, then it's correct. So it will sometime correct, sometime not correct, but not surely correct. So we have to just take the 0 case will handle by this, mid case handle by this. If it's 1, then it will move. We will have to do this, but this case is. So yeah, let's see. So yeah, saying AR is not declared because it's a. There is some error. Where is error? But wait a minute. Where do we have to short? We have to short till n or till high? Because till high plus 1 and array is already shorted. You don't have to do anything. So you have to do till mid to high, not mid to end. So yeah, all test cases passed. This is DNF Algorithm.
So hello guys, I am explaining Dutch national flag algorithm. So in this algorithm what we have to do is we have to make 3 pointers, like I am making pointers low, mid and high. Low is representing zeros, mid is representing ones and high is representing twos. So what this algorithm says is count of zeros is always from starting point of the array 0 to low minus 1. In this range there is zeros, low to mid minus 1 there is ones, and high plus 1 to n minus 1 there is twos. So we have to arrange things like that. So what we have to do is we have to run a loop and we have to arrange pointers like where 0 will shift, where 1 will shift, where 2 will shift, and after shifting all the elements we can say that we can see that the array will sorted in zeros are zeros in the left part of the array, twos are the right part of the array, and in the middle of the array there is ones. So we have take an example and see how this algorithm will do things. So I am examining a simple example. So let's take an array 0 2 1 2 0. Let's take this. So what this algorithm says is if you have 0, then what we have to do, if you have zeros then you have to put, if you have 0 then you have to put in the left part of the array 0 to low minus 1. If you have 1 then put here, if you have 2 then put here. So we have to so we have taking 3 pointers low, mid, high. So what I'm doing is initializing low as this is starting of the array, mid is also starting of the array, and high is end of the array. It's high. This is clear? Yeah. So now now check ARR of mid is what. So in this case ARR of mid is 0. So if ARR mid is 0, then what we have to do, we know one thing, this is array, like imagine this is array, imagine this is low, this is mid, this is high, imagine this is the array, imagine. So if mid is 0, then where we have to put it, we know 0 till low minus 1, this is sorted and all part is 0, but we know just after low minus 1 there is 1, so we have to replace that one with 0, then this part is sorted. So what we have to do, if it is 0 then we have to go just upward, or we can say we have to swap this and this. We have to swap ARR of mid and ARR of low. When we swap these, this 0 will come here, then we can say 0 till low minus 1, not 0 till low is sorted. So low move here, and what happened to mid? So this mid there is 1. We can say this part is somehow sorted. We can say this part is also sorted. So we have to mid forward, because we can say this part is sorted. Here is ones, all ones are here, so this part is sorted. Now we have to sort mid plus 1 till n minus 1 sorted, so mid plus plus, mid moves further. Again we move to next, so mid goes here and low goes here because this is sorted, so here is low. Now we have seen AR of mid is 2, so we have to do this thing. AR of mid is nothing but 2, so we have to do is, if AR of mid is 2, then what we have to do is, so we can say it's 2. Imagine 2 something here there is 2 because high pointers is here. So what we have to do is we have to move 2, so mid is here, something here, and it's 2, so we have to do is we have to put in the right part of the array, so we have to something here. So what I am saying is we have to put in the right part of the array. So yeah, this is high plus 1 to n minus 1, and yeah. So what I am saying is till high plus 1 till n minus 1 there is 2's, so this is sorted. Here all what this approach says, here all 2's, so this is sorted. But before high plus 1 there we can't guarantee is sorted or not sorted. So this part is sorted, just before this is not sorted, so we have to change this to 2 so that this part is sorted. So we have to change this with this. So what I'm saying is swap AR of mid and ARR of high, because this is high plus 1 and just left before this is high. So yeah, so we swap this. Now what we have to do is we have swap this with this. Now high is here, we can say this part is already sorted, now this is sorted, so high goes here, so high reduce. Now we have to change mid or not. So what I am saying is, suppose there is 2, and this point is suppose 0, and in the right of the 0 all is 2, left we don't know, or here is 2, so we have this 2 here, 0 here. Now if we change mid to mid plus 1 like we have did in this part, so if we change mid to mid plus 1, then what happen, this pointer, this is 0 and this move here suppose 1 2 0 कुछ भी anything. Now this 0 is a problem because before this 0 there is 1 and this is 0, but this 0 can't be there, this 0 is there, so we have to move this 0, so we can't move mid. We have to check this, if this is 0 then this condition met, then this swap and this thing happen, so we can't do mid plus plus here. There is no need of that, okay. Now third part, if ARR of mid is nothing but 1, so what we have to do, so we have low, mid, high, so this is 1, so what we have to do, is 1 at the correct position or not? We can say before that is 1 1 1, we can say yeah, that is in the correct position, so we don't have to do anything, so we can clearly say mid, we have to go further move. And where we terminate the loop, we can say that mid is here, then mid goes here, mid, we can say first mid is here, then mid goes there, mid goes till n minus 1 full arrays. So we can say while mid is less than n, we have to perform these operations, as simple as that. Now discuss the time complexity of this algorithm. So the time complexity of this algorithm, we can say mid is so how much this loop runs. Let's imagine we have to perform this operation. This is 0, then we perform swap and then move. If 2, then swap and then moves. If 1, then moves. So in one of these operations we have to do one operation. So in this n operation we have to, how much operations we do? N operation. The time complexity is big of n. Or you can understand by this this loop is linked till n time, so every time mid changes if it swaps, if the pointer moves, then here, if the all is different, if all is twos, then let's go there, if all is ones, then something changes, so till n is running. Or you can check using a variable count. You can initialize count and then to count plus in every iteration, and in the end you can see that count is nothing but n, so you can say time complexity of this algorithm is big of n. And this is the better approach of doing this question.